So hello everybody and welcome back. This is part 2 of the little compressor repair, and believe it or not, I got new bearings, and these two bearings were, I think, €4, so extremely cheap. And I've spent some time looking at whatever I got here. I checked the motor coils because I'm not sure that the motor itself has a non-resettable thermal fuse. That would be a bummer if we fix it now and the motor's not working. As far as I can tell, that is not the case, but I'm not 100% sure. So it could be that we're fixing it and it still won't work. The other thing that I came across, and that is kind of odd, I took a look at the parts here, and if you look down here, you can actually see that there's, I don't know, there's quite a lot of deformation going on in the base of the cylinder. I don't know what the deal is, and if I look at the counter shaft, I can also see that there's quite a bit of damage on here, especially at the highest point. So could it have been that this thing was hammering against the cylinder wall, and it was basically hammering against the bearing, and that caused it to fail? Because I think this is, from manufacturing wise, this is pretty good, and if they got the counterweight correct here, then there shouldn't be too much load on the bearing at the end of the motor, apart from the thermal load, because all of this gets hot, of course. So either the bearing just failed, or maybe there's something wrong with the excenter here, and maybe we can just, when we put it all back together again, we can just place this a little better, and then it'll just work again and have a better chance of staying working. The other thing that I found was that there's some foam material in here, which is supposed to be an air filter, and I replaced these when they were supposed to be replaced, but I think this one failed catastrophically. So it is basically all in here, and I think some of it may even be in the tank. I don't care for that right now. I just want to see this thing basically come back. Now, I pulled the bearing off the rotor from the motor, and it wasn't on that much. It was really easy to pull off. I thought I would really have to fight this, seeing how I had to fight to get the excenter and everything off. It was just, I thought it would be quite a lot of work, but this thing just popped off like that. What I did find is there is rust on this side of the motor. Maybe because of the heat. I don't see how it could have gotten in there just like that. But this side of the motor looks a lot better than this side does. So I'm just guessing it has to do something with the heat that this side is experiencing, which is generated by the compressor part. So this is the new bearing installed. Just for reference, I used the old bearing on top of this one to get it started, and I pushed it in just with a hammer, and when it got too tall, I started using a socket which fits over the bearing and just touches the inner surface. You do not want to put load on the outer surface because it's just going to damage the new bearing. But that went really easy, and no problems with that. So let's get this little piggy back together. I think the motor from the top actually looks like a little pig. Imagine 2 eyes here, some ears, and it just needs a little snout down here. I did not spend a lot of time cleaning this up because it is pretty clean. There aren't any metal shavings in there, so I don't see any reason to go overboard cleaning this. I am going to try and assemble it the other way that I took it apart, by seating this side of the shaft first, and it just slips in, so it doesn't take any force to put this thing together. Then after that, we can just slip the backside on, but there are some metal shavings in the back of here, so we'll just carefully clean that out. Once again, not going overboard. These bearings do not require any lubrication. There wasn't any Loctite in here to begin with, and I think the whole thing wasn't very loose, and I might have changed that when I was wailing on it with a hammer just to get it apart, but I'll see if this thing goes back together some way or another. And it might need a few taps with a hammer, but yeah, I'll just tap that together. Be right back. Well, I have it back together, and I tried to get the halves of the shell on as good as I could, and now the motor fits in here a lot better than it did when I started out. And as a matter of fact, since the screws are holding it in from the outside, while the screws that hold the compressor part on go all the way through, I wonder if the whole motor was basically slightly kinked to the top, and that made the bearing ride very unevenly, and maybe that also contributed to the fact that when they put the piston and the what is it called? Well, this part on here, they got it slightly crooked. So when it was on, it was actually touching, it was actually riding on the outside here. But looking at it now, this doesn't really make any sense. I think this mangled surface comes from something else. It must be part of the production process. But it's very interesting. I don't know how I'm going to get the piston back on, because this part probably needs to be heated to fit over the motor shaft. But I can't really heat this thing because I'd be destroying this bearing here. So I don't really know how I'm going to go about this. If I'm going to try to get this separated from the piston, or if I just try to heat this up and just put the motor in an ice box just to get it cooled down. But I'm pretty sure that just really icing the motor is not going to be enough to get this to slip over the motor shaft. That is a very tight fit, and I'm pretty sure that it is meant to be mounted at temperature. So let's see how we can go about that, or if I just use brute force to get it back on the way I did it right at the beginning. Not sure. So let's see where this goes. So it's finally back in. It took me forever to get the eccentric drive back onto the motor shaft, and I don't know exactly why, what the reason was that it was so hard, but the shaft was actually slightly damaged. It wasn't smooth, so I actually had to take a file and like take a few tenths off of there, and it took me a while to get it, first of all, to get it done, and then I realized that it is really, really hard to line up the piston with the cylinder the way that this is constructed. And I think I have it at the best right now, although I don't know if it was always like that. I can't imagine it was different. It just seems that when I spin the piston in here, it does have this wobbly movement that is normal, but it also has a slight front to back movement. And that was what I was already seeing when I was taking it apart, that at some point it would bind up to the sleeve and it would just move the sleeve up and down. No idea where that is coming from, if that always was like that and if it just doesn't matter. I don't know. The thing that I know is that the bearing that is holding the piston is probably going to have to settle over time, and I hope that it does, or else it's going to break. But right now the piston is moving where it's supposed to, and it's doing it pretty nicely. I don't think it's doing it as well as it did when it was new, but we're getting there. The next thing that I need to do is I need to get the compressor mounted with the screws that give the motor and the bell housing pressure, because this pulls the motor together and this gives it its final resting place. I don't know why they had the mounting screws so tight, but I think it's designed that you mount the compressor to the motor, and then you tighten down the screws that hold the compressor and the motor to the tank, and these will then deform. It can't be anything other than that, because then you would basically you would cause a misalignment between motor and compressor. So I'm going to try to do it that way. Let's see how I can get it done, if it lines up correctly, and if it does, I'm just going to mount it to the tank again. I think I have everything else that came off of there back on it right now, so once I'm done with that, I can just continue putting it back together, and maybe before putting it together again, there's a possibility of actually testing if the motor still works. Also, while I have the chance, I'm going to try and take the air filter and all the rest of the pieces from the foam material that are in there. I'm just going to try and take it all off and get everything here cleaned out as good as I can. And then I'm going to have to see if I can make some sort of new air filter, because I think this one is yeah, this one is done for. Well, it's not as bad as I thought it would be. this here's the air filter. It's just a piece of foam. Let's see if I can get something like that, or if I can make something very much close to that. If not, it's gonna go back in until I have something that fits the description. Okay, so let's get something to clean this off. Some brake clean should do fine. I'm pretty much amazed at how little wear is actually visible on all of these parts. The way that the piston and the seal work seem to perform very well and keep everything well lubricated. As long as these things don't overheat catastrophically, I think they are basically indestructible. Let's take this off. Give this one last wipe down. I really don't like the inside of this, but I don't know what to do about it. I'm not sure that I can take a file to that. But what I am worried about is somehow some of these aluminium shavings making their way up into the piston and the seal, because that would just ruin everything. But I'm not sure that I want to go in there and do something to it. So we'll just leave it like that. Okay, that is clean. Just cleaning it off makes it a lot easier to get it properly greased up when I'm done with it. Also not here. Let's see if this sits down nice. Yeah, that's good. And let's put some tension on these and pull this all together so it sits perfectly the way it was designed to. There probably is some sort of torque spec on this, but it's an iron screw in aluminium, so I'll just be really careful. And yeah, well, it's not working as great as it was when I put it all together. Loosening the screws a little bit, so maybe we need to release some tension from the case. Let's see. Well, there's some drag on it, but I think I'm just going to let it run that way. That's what I thought. Actually, tightening one screw over the other is going to seat this thing better. So maybe all the bearings just aren't quite there where they're supposed to be yet. Yeah, it's okay. We'll just let it warm up and maybe it'll seat itself. Good. So the next thing I'm going to look at is the sleeve. There's a lot of grease in the sleeve, which is fine. It doesn't say that the whole compressor is grease-free. It's just oil-free. And I am going to grease it up again. Just making sure that we're not really running on the sleeve itself. A little bit. That's what I was afraid of. So I gave this thing a slight whack, and it gave a little bit. Not 100% sure that it's all right yet, but yeah, it's pretty close. We're just very slightly touching the wall in the back of here on the sleeve. I'm gonna let it run before putting it together finally, and we'll see if we actually rub on it or if it just settles itself. The next thing that I need to do is I'm going to have to clean the gasket that's under here. I've inspected it and it does have some run in, but I think we can just rotate it a little bit so the area where it's worn the most are now where it's basically where it doesn't have pressure to the wall that much. Well, at least I hope that when I do that, it somehow helps it. All of this was actually greased down really well. And even after these 15, 16 years, that grease is still really, really good quality. It's just working out. I'm not sure that when I took it apart the last time that I replaced the grease. Could have been, I just don't remember. I don't know. So, gasket goes in here. And then we have the top part of the piston. This is where the excess grease goes. Well, basically there's a cavity here, and you just fill that up with grease. And each and every time that it heats up, the grease is going to get soft, and it is just going to run out onto the gasket, and it's going to basically make sure that the gasket is always well lubricated. And I think that's a really good idea. There are actually some marks here on the top side. I don't know if it took in something and if it spent some time hammering it. No idea, but this is not a gas engine. It doesn't really make a difference. So let's get some high quality grease in here. I think using this type of grease, which is it's an acid-free ball bearing and roller bearing grease. That is probably absolutely overkill, but if I don't use it up, it'll just go bad, so just let's use it. Okay. Good. Let's see if that was enough or not enough. Yeah, that's good. And I'm going to add one extra layer of grease around the gasket, just to make sure. All right, that's that. That goes in here like this. And this screw holds it down. Is this the right one? Yeah. This screw is very worn. I'm not sure if that was my fault. It could have been, but I don't remember. Oops. And now that it's down, it's going to press most of the grease that I just put in there out through the edges, making sure that we have good lubrication. Good. So, yeah, I could spin this by hand, so it's not too bad. But I can also use the fan wheel. That should, yeah, that makes it easier. So let's line up the gasket. Here we go. Yeah, and that's it. If the motor still works, this thing should pump air. If the motor's busted, then it's time to take it to the dumpster. To the recyclers, of course. In Germany, we don't have dumpsters for electronic stuff anymore. Everything needs to go to the correct recycler. Okay, back again. The screws down here gave me one hell of a fight, and I just did this off camera. Also, I reattached the power to the pressure switch, and I added some screws from the top here with nuts at the bottom that are going to hold down the sleeve so we can turn it on to check if the motor is still all right. And just like give it a second of operation, see what happens, see if it jumps off the table, see if it goes boom. I'll tell you right now, I've already tried it because safety things like this, don't do it with the camera running, because if something goes really wrong, you'll be following the camera, not what's going wrong. So I'm going to try this out now. You're going to see what happens, but I already know, so the video is up. I didn't die. So here we go. I'm going to turn it on. This thing is fixed down. I have the fan on. It doesn't need to be, but I couldn't get it off, so I left it on. Also, this thing is just loosely tied down to the tank, so it's probably going to be a little bit bumpy. Well, let's see what happens. Wow, it appears to be working. Great, so we know we can continue with this. I can start adding the parts for the top of the cylinder, which, just if you're interested, this just contains 2 chambers. When the valve is on, the valve will allow air from the outside to go into the chamber of the cylinder, filling it up. It will then lock the air inside here, and the second valve will only open if the pressure inside the cylinder is substantially greater than the pressure behind here. That's the way that they make pressure. This thing goes on top of here. There is a gasket here, and the cylinder head, if you want to call it that, has its own gasket. This gasket is in really bad shape, and I'm not going to try and do anything with it, because as you can see, parts of it have already disintegrated, and if I can get this tightened down to the point where it's airtight, I'm going to be happy with it. But I'm not going to try to clean anything behind it or do anything to that, because that's just asking for trouble. Okay, so let's get these out and get the nuts removed so we can get the valve section. I don't actually know what this piece is called. I couldn't find it on any description. We'll just try and get this thing fired up, compressing, and then we're going to let it run for a while and see what happens. I'm already happy that I got it fixed to this point. Not sure that I'm ever going to use it for big jobs again. But who knows? The other compressor I bought might just be junk in some form. And I'm going to be happy that I have this one. You really never know. I'm not going to tighten this down with excessive force right at the start, but I'm moving the cylinder a couple of times and opening it back up so everything can settle the way it likes to settle the most, and so we don't have any excess pressure on any parts. And once I'm done with that, I'm just really carefully going to snug these down. I don't know, 15 foot-pounds of torque, 8 to 15, I think. It's more like 8. I mean, everything here is aluminium. These screws are stainless steel. And you don't want to strip out anything on this thing. So let's be really careful. And these screws are accessible when everything is together, so this can run for a couple of minutes, hours, whatever, and we can still check these screws. Great. So now it should be compressing, so we might actually hear it. Oh yeah. So we actually have some compression in here, which is great. And let's just see if it will build just a little bit of pressure if I let it run for another second or two. Oh yeah. Nice. Really nice. Okay, I am now going to tighten the screws holding the compressor to the tank fully, and after that I'll let it run for a little bit longer and see if it builds pressure on the gauge. I think that's a safe way to go. Also, I know why these were tightened down so, well, overly, because whoever did it, I think, did it wrong. You're probably supposed to first tighten the ones at the front and then the ones at the back, and I think they did it the other way around, but who knows? Who knows? It's been a long time ago. Okay. Okay, I migrated down to the ground. It's just a little bit safer there. I added the fan shroud just to the point where I think if anything goes wrong in there, it's just not going to hurt me. And I want to run it for, I don't know, 15 to 30 seconds and see if it builds pressure and if it holds pressure. If it doesn't, this whole thing was a waste of time. Here we go. And the answer is yes, it does. So we do have a little bit of pressure in there, just above 2 bar. That is okay. I would actually call this fix a success. It didn't run for a long time, but it didn't even get warm right now. It's like, yeah, nothing is warm. It doesn't have any electrical smells. All blue smoke appears to still be inside. And yeah, let's call this fix a success. Nice. The motor is not warm at all. Neither is the capacitor. I'm going to put it back together up to the point where I can just test it for a longer time, and we're going to test it and see what happens. And if it's fixed, then it's fixed. If there's something else wrong and I just didn't realize, well, so be it. Right now, I'm happy. So here we are. It's back together. I tied down all the air hoses and cables in the inside with cable ties, made sure that everything is secure and nothing can touch the fan, for example. It's completely working as far as I can tell. Let's see what time makes of it, but right now I'm extremely satisfied with this. It appeared to be completely broken, nothing was working at all. It turned out that it was just this €2 bearing. That was kind of hard to replace, but in the end it worked out very well, and I couldn't be happier. One machine saved from the dumpster, and I'm pretty sure I'm going to find something for it to do. First thing it's going to do is it's going to run through a couple of cycles, and then let's just see. Thank you very much for watching, and bye-bye.